Hello guys, here I'm going to talk about capacitors. When considering about the capacitors, there are two ways to connect the capacitors. There are two ways have that connected in capacitor. One is the series and other one is a parallel. When considering about the series condition connected in capacitors, when capacitors are in series condition, this is the way how it's connected with the battery. Here C1 capacitor, I assume this one as a C1 and this one as a C2 and this battery as a E. In order to consider this circuit, we can redraw this circuit as an equivalent circuit. Okay, then we can redraw this circuit as an equivalent circuit. CEQ, I assume this equivalent capacitance and as a C equivalent, and this one is E. Then we can write this equivalent capacitance as a formula. Then here we can write the formula C equivalent, which means 1 over C equivalent 1 over C1 plus 1 over C2. This is the two capacitors when connected in series. This is the formula when two capacitors connected in series. But here another capacitor here connected here, I assume as it's C3 capacitor, then it looks like the formula is like this. Another capacitor, I assume that as a C3 C4, then its formula look like this. When we can add many capacitors for when series connected in series, then we can add n number of capacitors for this formula. Okay, finally this is Cn. Likewise we can write n number of capacitors, but here it's only have the two capacitors. Hence that we can simplify this circuit like this. We can simplify this circuit. C equivalent equal C1 C2 divided by C1 plus C2. This is the formula when two capacitors are connected in series. Okay, the next important thing is how the behavior of the charges when the capacitors are series connected. Okay, here the capacitors, two capacitors and connected with the battery. This one is C1, this one is C2. This battery has a Q amount of charge, then that Q amount of charge, it's not separated between two capacitors, because this capacitor has a Q amount of charge and this capacitor has a Q amount of charge. The charge does not divided in both. Okay, it's go the same charges between two capacitors. Then other thing is charges amount of charge, both capacitors are the same, but the thing is voltage across these capacitors can be changed. It is changed. Okay, C1 capacitor across the C1 capacitor voltage I get as a V1 and C2 capacitor as a V2. Then we can write V1 voltage, V1 equal C2 divided by C1 plus C2 multiplied by E, and then Likewise, we can write V2 C1 divided by C1 plus C2 multiplied by E. Always in here numerator, when it's V1, then its numerator is we write C2, and V2 we write C1. Likewise, we can write the voltage across the capacitors. The here very important thing is, when connected in series, when connected in series, when connected in series charges does not change. Both capacitors, because it has the same amount of charge between the C1 and C2 capacitors. Okay, next one is capacitor when it is parallelly connected. Parallelly connected cap. Okay, when parallelly connected, this is the circuit of the parallel connection of the capacitor. This one as a C2, this one I get as C2, and this is the electromotive force, which means the battery. Then we can redraw this circuit as a equivalent capacitance. This EQ, this one is E, and according to this equivalent circuit of the equivalent capacitance, we can write the formula for equivalent capacitance. That is C equivalent equal C1 plus C2. This is the way how to write the equivalent capacitance when capacitors are parallelly connected. Here we add some more capacitors for parallelly connected. Okay, we can add n number of capacitors for here. Okay, I add another capacitor here, and we can add more n number of capacitors with the C1 and C2 in parallel condition. Then we can write plus C3 plus n Cn. You can write this formula as a to get the equivalent capacitance. Then, but the thing is, here equivalent capacitance in the two parallelly connected capacitance formula is this. Okay, when considering about the charges, before I mention about the charges, how the behavior of the charges of the when capacitors are series connected, then this very important thing is then how the behavior of the charges when capacitors are parallelly connected. Then here's the thing that you may have to know, very important thing. This is if we connected capacitors in parallel condition, C1 and C2, and this one as a equal, and this, okay, I'll consider this E has a Q amount of charge. Okay, but the thing is here, when in parallel condition of the capacitors, we do not know how many charges, okay, how many amount of charges when goes to the capacitor 1 and capacitor 2. Okay, then here in parallel condition it's divided the charges. Okay, and then I will get this one as a Q1 Q1 amount of charge, and this C2 capacitor has a Q2 amount of charge. Okay, then we can write Q equal Q1 plus Q2. This is very important condition of when capacitors are parallelly connected. You have to know these theories and to get solve the question. Okay, here these are the theories that you have to know about when you are going to the capacitor equations when it is connected in parallel or when connected in series. If you like this video, then you can thumbs up and subscribe the channel. Thank you.